Hi. Um, Hopefully you guys had a good lunch. My name is Arun Murthy. I'm going to spend the next half an hour, 45 minutes talking to you about sort of, data processing in the Apache Hadoop ecosystem, sort of look back, look forward, and hopefully try and give you a perspective on, how things are, how things have been, and, sort of what they're going to look like in the future. A brief introduction. My name is Arun Murthy. I'm one of the founders of Hortonworks, your host for the day. I've been, doing Hadoop pretty much since day one. Gosh, it's been about 7 years. It's been a long time and a lot of fun. A lot of, interesting experiences. Previously, I was at Yahoo running, Yahoo's Hadoop MapReduce cluster. Responsibilities included code configuration, operations, for all of 45, 50,000 nodes of Hadoop there. And as with most people in the Apache Hadoop project, I sort of wear two hats. One is sort of my corporate hat. The other is what I do in the Apache Software Foundation. Every line of code I've written for the last 7 years has gone there. So in the ASF, I was the former VP of Apache Hadoop. Really, really long-term committer. Also an ASF member, and also currently I also function as the release manager for Hadoop 2.0, right? So, I'm going to tell you a story now, right? The story is, what do you do with Hadoop and, where it came from, right? So long, long ago, what do you think of Hadoop? Was very, very different, 3 years ago, was different 5 years ago. It'll be different, 5 years from now, right? So as we sort of look back, in Apache Hadoop, when I started on this about 7 years ago, Hadoop had basically just, two things, right? It had, HDFS, it had MapReduce, right? So on every node in your, Hadoop cluster, you would actually run HDFS and MapReduce concurrently, right? HDFS was all about storing data, right? HDFS didn't care whether it was, CSVs or text or binary formats or whatever it was. All HDFS did was it stored data in a simple file and directory hierarchy, which you guys are familiar with. It didn't care what the contents were. It didn't care about semantics. It still doesn't, right? That's one of the great strengths of HDFS. Now, obviously, over time, HDFS has changed a lot. Unfortunately, I won't have enough time to cover all of it. So let's just say that for now, HDFS continues to store data. It continues to store files and directories. It might change, tomorrow. It might change the day after, but it's going to look different. MapReduce was the only way to process all the data in HDFS, right? So if you went back 7 years, you had HDFS and you had MapReduce. And essentially, as an engineer, the way I looked at it was, MapReduce was the only algorithm you could run on all this data that you had. You could store petabytes and petabytes of data, but the only way to process it was to do MapReduce, right? Now, MapReduce is a fairly simple way to process data. It's about taking your input data, chunking it, processing them in parallel, and then doing one single aggregation step. It turns out that even its simplicity is its strength, which means you can build systems on top, and many people build systems on top, like Hive and Pig and so on, to actually use the MapReduce paradigm and process data at a higher level language, right? Obviously, MapReduce gave you the Java API, but Pig gave you, a data flow language, Pig Latin. Hive, of course, gave you the SQL to process it, right? So, things were great for a while. Everybody was happy. And, I'm now going back, 3, 4, 5 years in time, where MapReduce was there. Slowly, we were starting to see other things come into the Apache Hadoop ecosystem. Definitely, HBase was a very welcome entrant. HBase offered a key value store or a NoSQL store on top of HDFS. And slowly over time, HBase itself gave more and more features like co-processors, if you guys are familiar with it, to actually process data within the context of HBase. However, people wanted more, right? And you want more and more, which meant what you have is people start saying, I've got MapReduce, I've got Pig, I've got Hive. As Matt talked about and Sean talked about in his talk, as people began to see value in HDFS and MapReduce, And people start getting comfortable and familiar with the aspects of processing, the batch processing and ETL and so on that you got with HDFS and MapReduce. Naturally people wanted more, right? I mean, and it's completely reasonable because I was at Yahoo as I went through this sort of growth curve where we went from having 100 nodes to 500 nodes to 1,000 nodes. Next thing we know, we're at 5,000, 10,000, 20,000, 40,000, right? As you start investing, tens, if not hundreds of millions of dollars of CapEx and OpEx on top of MapReduce and HDFS, naturally people wanted to see more, right? So what is, it turns out that, that definition of more changes. Obviously SQL, like I said, Hive was a really big step because it offered fireworks. No. So SQL is obviously one of the really big things when it came to processing data because as Matt and Sean were talking about, there is a whole army of analysts out there who understand SQL, and clearly allowing people to process data in a language and medium they're familiar with was really, really important for the evolution of Hadoop. Now, it doesn't stop there. Things like machine learning is really important. People have all this data on Hadoop, and they want to be able to model through machine learning, whether it's R or Spark or any of these tools. They want to be able to build models which allow them to do predictive analytics, figure out is this customer going to be valuable? I was talking to a bank in the last few days, still have issues. Check. Yeah, so people are trying to get analytics and figure out if this customer is somebody we need to upgrade, I don't know, to a gold, city gold account or whatever it is, right? So these sort of predictive analytics naturally require more than MapReduce. MapReduce is, most of you guys are fairly familiar with it, is a fairly straightforward sort of one-step process. Now, when it comes to machine learning and modeling, what you want to do is build a model in your head, then pass that model along to all your peers, get their feedback, and then iteratively continue to build that model until you converge on a solution, right? So these are extremely common use cases when it comes to modeling. Similarly, you'll see more and more people start thinking about things like real-time event processing. That's different from sort of the interactive query cases. What I mean by real-time event processing looks more like complex event processing, if you guys are familiar with it. You're getting events in real time. You're trying to trend, the Twitter use case is common, right? You're trying to trend, where the tweets are coming from, where they're coming from, what is the, sort of the popular trend at this point, and so on. So all of these things are absolutely valid in the Hadoop ecosystem as it continues to mature. And as people put more and more investment in Apache Hadoop, these use cases become more and more interesting and more broad, right? So that's kind of the feeling I want to leave you guys with. So as we started looking at this, it was pretty clear even 3, 4, 5 years ago that HDFS was actually, like I said, HDFS provides you a basic file and directory system, which actually turns out works really well for storing data of all kind. But MapReduce was actually too restrictive, right? Now, what it meant was, as we started looking at MapReduce, or as somebody who designed the MapReduce system in Hadoop, the way I looked at MapReduce was actually fairly straightforward. To me, MapReduce actually meant two different things, right? One part is what I call the user framework. The user framework is what the end users write their applications in. They write mappers and reducers and input formats and output formats. And then they take that job or jar or whatever you want to call it and submit it to what I call the MapReduce system, right? So the MapReduce system is the one which is responsible for taking your job and sort of running it to completion, right? It will deal with resource management in your cluster. It'll deal with failures in your cluster, so on and so on and so on, right? So as an example, when you submit a MapReduce job, the first thing that your job tracker does is It takes your job and figures out how many tasks I need to run. It will schedule those tasks on the appropriate nodes. Hadoop MapReduce is really good when it comes to moving data, moving compute to the data, what we call as data motion, which is it will not try and move data to the maps. It'll try and schedule the maps on the data nodes on which the data is present, right? So that's one of the key aspects of efficiency when it comes to MapReduce. So all of these things are taken care of by what we call the MapReduce system. And we knew that for a very, very long time that the MapReduce system was so ingrained. MapReduce, the concept, was so deeply ingrained in the system that you could not use that system for anything other than MapReduce itself, right? So that sort of explains why MapReduce became the base or the assembly language for the big data or the Hadoop ecosystem, right? So what did we do, right? When we sort of understood all these issues with MapReduce as we spent the first couple of years working through them, it was clear to us that we had to separate out MapReduce, the framework, from MapReduce, the runtime, or the MapReduce, the system. So the way we went along is we designed this new system called Apache Hadoop YARN. I don't know, how many of you guys have heard of YARN? Oh, cool. So YARN was an attempt to actually separate out the MapReduce system from the MapReduce framework. And this meant that we could now have a generic resource management system, right, with YARN as that resource manager and the node manager. And we could separate out the resource management aspect of MapReduce from the MapReduce semantics of the application itself. So the way YARN works is it's now got a distributed sort of system, application system, a resource manager which allows you to get resource in the system, and now a MapReduce application to go get resources from the resource manager and get work done, right? So this was sort of the centerpiece of the new Apache Hadoop system, which is what we call Apache Hadoop 2. So what this meant was MapReduce is now merely relegated to being one of the applications in the Apache Hadoop ecosystem, right? And that's a really, really important transformation in Apache Hadoop itself. This now means that you can now write different applications to do better SQL, applications to do machine learning, applications to do real-time event processing, and get all of these to run in your Hadoop cluster itself, right? And this is a really, really big deal because all of these applications can now share the data that you have in HDFS. And this really, really opens up the Hadoop ecosystem to do much more. And as we talk to customers, you now get significantly better return on your Hadoop investment because you're now no longer limited to being MapReduce, right? So far, you could do this, you could do real-time, you could do machine learning on Hadoop. But what it meant was you had to have a Hadoop cluster to do MapReduce and a Storm cluster to do real-time or an MPI cluster to do modeling and so on, right? Now, what this meant was you can get all of these in the same Apache Hadoop cluster, and that's really, really big. So, like I said, we now are at a place where we've got YARN, we feel, as in a significantly stable fashion at this point. You'll see, for example, Apache Hadoop 2 become GA later part of this year. You'll see Hortonworks distribute HTTP2, which is going to be based on Hadoop 2 later part of this year. And we've been doing a lot of work with folks like Yahoo, who've deployed this at extremely large scale, and we're very, very thankful for all the work they've done in helping us stabilize YARN itself. So we sort of kind of get to a point where now MapReduce becomes one of the applications, right? But it turns out that MapReduce is still sort of the centerpiece of the ecosystem because things like Pig and Hive still depend on MapReduce, right? So when you write a SQL query with Pig or when you write a SQL query with Hive, what Hive will turn around, the optimizer and the parser in Hive will turn around, take your SQL query, break it up into a set of MapReduce jobs, and run them on YARN itself, right? So that's kind of the way you see MapReduce evolving. Now, it turns out that MapReduce is not necessarily the right application API to do SQL, right? A very, very common issue we've known forever, and there's been like a big cottage industry on writing papers on why MapReduce is the wrong system for SQL. I've read those same papers for a long while. Essentially, the fundamental issue with MapReduce is MapReduce offers you a single aggregation step in your entire job. What I mean by that is you have only one effective sort or an aggregation step in MapReduce because you've got a map, set of maps which do processing, and then one stage to do aggregation, which is your reduce, right? And it turns out you only get one kind of aggregation, which is a sort-based aggregation, right? So between the map and the reduce, you have to have a sort to actually get you the aggregation. Now, if you sort of think through the implications of that, you get two kind of problems, right? One is you cannot express all of SQL or all of pig in a single MapReduce job. This results in us having to run multiple MapReduce jobs to run the same SQL query, right? And in between your multiple MapReduce jobs, you now have to persist your data or the intermediate data to HDFS, right? And that it doesn't matter if you're running a small query or a very, very large query. That's an extremely high overhead, right? So that's one problem. The second problem, like I said, is since MapReduce only offers a sort-based aggregation, you are actually paying the cost of having to sort your data, even in cases where you don't want to. A common example is a group by, right? If you're trying to do a group by in your SQL query, you could, depending on the data sizes, you could actually get away by just doing a hash-based aggregation and not a sort-based aggregation. A sort-based aggregation is necessary in some cases where you can't keep some of the data in memory. But in a lot of cases, depending on the query size, you can actually get away with a hash-based aggregation, right? So what I've been personally working on for the last probably 6 months or so is a new project we call Apache Eighttails, right? Now, Eighttails is sort of designed to be a lower-level API than MapReduce itself, right? And it's designed to offer a significantly more complex DAG of tasks for Pig or Hive to rely on. And what I mean by that is if you look at MapReduce as a simple DAG, it's got basically just two vertices in it. It's got a map vertex and a set of maps, followed by a reduce vertex and a set of reducers. So logically, it's just got a map and a reduce as two vertices in your DAG, right? And like I said, if you're trying to do things like a join followed by a group by followed by an order by, these cannot be expressed as just two of these vertices. So you require multiple jobs to express them. Now, what Tez allows you to do is actually to get you that join, group by, order by as individual sort of logical or a more complex vertex within the same application itself. So this means that you can take any single SQL query or Pig or Hive or even Cascading or whatever it is, and express them as a single job with a significantly more complex tag, right? So this allows us lots of advantages. One thing is we obviously don't persist the intermediate output on HDFS now, right? So we don't have to do that. We get away from doing that. We also allow you to now get you significantly more complex interactions for your intermediate data, which means you can now do group-based aggregation or a hash-based aggregation, a full sort or a specialized sort, and I'll talk more about them. And the nice part about this, about doing Tez, is it will still continue to run in your YARN cluster, right? So what this now means is you have in your YARN cluster, MapReduce and Tez are just two different applications, right? So these will coexist along with your Giraffe application or Spark application or whatever it is, but all of these continue to run within YARN itself, within the context of the resource management framework that is YARN. And this is really nice now because we can experiment with MapReduce and Tez at different paces. We can continue to keep MapReduce. We can continue to keep that as the sort of the stable system while we invest more and more in Tez and get it faster and get it to stabilize faster and faster without having to risk anybody who uses MapReduce at all, right? That's really, really big as somebody who actually works in the system. In the past, I was very, very scared of making any changes in Hadoop 1, simply because every time I made a change to MapReduce, A, I would expose every single user in the world to those changes, right? And B, I didn't have a way to safely provide a change to a single user in the cluster, right? So if I had to do something like MapReduce reduce or YARN in Hadoop 1, I had to go change the task tracker to the job tracker. And every time anybody used it, I was exposing everybody in the world to it. Now with YARN and Tears, I can just do it for the individual user who cares for that performance, because everybody else can continue to use Hive on MapReduce if I want. Does that make sense? So it allows us that degree of flexibility and freedom, which I never had as somebody leading the project. And that's a really big deal, just from YARN itself, right? So what this now means is, because there's such a significantly more expressive language, I can now take Pig and Hive, and actually even MapReduce, and just compile them down to Tears. So the world which we sort of live in today is we have Pig and Hive, and they compile down to MapReduce jobs. The world you'll see tomorrow is that Pig and Hive and Cascading, they will compile down to the Tears jobs. And we can actually take MapReduce itself, the API, if you write mappers and reducers, we can compile them down to Tears itself. Right? So that's a really, really big change from sort of Hadoop as you know it. So YARN was like step one, and this is the logical extension of it. So YARN allowed us to break up MapReduce, the system. This now generalizes MapReduce, the framework. Right? So that's sort of the evolution you see. And what comes next after this? Who knows, right? There are lots of things we can do. There's lots of things we open up with YARN. Maybe one of you sitting in this room is going to build the next system, right? And we can, I'd love to, help you guys do it. So this sort of, like I said, last year was all about, in some ways, from where I see it, last year was all about things like NoSQL. This year is all about SQL. Next year, I don't know what it is going to be, right? Next year, maybe everybody is going to want real-time event processing. It turns out that Storm, how many of you guys have heard of Storm here? Fair number. So it turns out Storm already works on top of YARN, right? So you get your YARN cluster, you get Storm for free in some sense, right? So Storm already works. Maybe somebody will invent something new, right? Maybe somebody will invent a new processing paradigm. But, Spark is interesting. Spark already works on top of YARN, right? Giraffe is interesting. Giraffe is a graph processing language. It already works on top of YARN. So who knows what the next thing is going to be, right? What is the next big thing? It's real-time event processing. It's, SQL is sort of already here. And that's the nice part about being in this ecosystem is it's always, it's never dull. You always get to do interesting work. And I hope that with things like YARN and Tears, we open up things to a point where it gets simpler and simpler to do more and more things in Hadoop, right? Now, sort of on a more serious note, right? SQL and Hadoop, like I said, is sort of the new black. It's the big thing, all this time. We've spent a lot of time with, Stinger in the last 6 months or so. There are definitely a whole bunch of talks I'd encourage you guys to go to hear about the improvements we've made in Hive with Stinger. We've got queries which used to take 1,400 seconds, run in less than 40 seconds at this point by doing basic improvements without even using things like Tears at this point. We've got a whole bunch of improvements. We're also working on what we call vectorized query processing. A simple way to look at what vectorized query processing is, on modern CPUs, the way you need to process data is significantly different because of the pipelines you get in them, which means that with a deep pipeline, you can actually execute more than one instruction per clock cycle, right? So what this means is, as long as you can keep the CPU pipeline busy, you get significantly higher performance from your CPU. And as we have a prototype at this point, which is again, it's a sort of a synthetic benchmark where we can process 100 million rows per second on a reasonably modern CPU, right? 100 million rows per second is a lot. What this means is you now have to be processing a block of rows at once and not a single row at a time, right? Generally, SQL engines try to take the next row, filter it, process it, or aggregate it. With vectorized query processing, the idea is you don't take one row at a time. You take 1,000 rows and process them together within the same clock cycle or whatever, right? Now this, we've been working on this for a while. You'll see us, there are talks from Gunther and Owen I encourage you guys to go to. And the overall message is, having something like YARN is a really big thing because it allows us to do things like this within the same Hadoop ecosystem, right? We've done this by making incremental changes in Hive, and we feel we'll get better and better and better to a point where you don't need, an alternate system to do that in Hadoop, right? Like I said, we don't really know what the next big thing is. Will it be real-time event processing? Will it be machine learning? Will it be Spark? Will it be Giraffe? Nobody knows. But what I can tell you is that the aim of the Apache Hadoop project is to be able to provide an infrastructure where people building these frameworks don't have to worry about the nitty-gritty details, right? Details like resource management, when a node goes up or when it goes down, you don't have to be worrying about those things as you build your application. Those things, it turn out, are not only hard, but also really, really boring to actually solve, right? When a node goes up or a node goes down, figuring out why it went down or why it's slow is very, very hard, and you don't want to be doing it in the context of SQL, in the context of real-time event processing, in the context of machine learning. You want a system like YARN to take care of it for you, whereas the application framework developer can now focus on actually building his application. Does it make sense? So, like I said, the idea is to sort of play to our strength of, we have a lot of experience and history doing resource management and fault tolerance. We want to do it once, and we want to do it together for everybody in the ecosystem, right? That's a really important thing. So, I sort of want to, kind of quickly give you an overview of, how Hadoop looked. I want to open this up for questions. I want to make sure we have time for that. I know we're on a tight schedule. So this is what Hadoop MapReduce looked like, a couple of years ago. It had a job tracker and a set of task trackers. And the only thing you could run in this was map jobs and reduce jobs. So this is, like I said, this is the simple DAG that you get in MapReduce. You had, the logical DAG on the left, and the sort of what I call the physical DAG on the right. Now YARN looks like this. We've replaced the job tracker with a generic resource manager, and we've actually replaced it not just by one resource manager, but with a combination, right? So the concept we've added is this notion of an application master. And this application master is responsible for getting resources for that single job. So you can think of this as having a job tracker per job, right? So every job in this new system has a job tracker, except that he's not doing resource management, he's just doing application management, right? So the way I look at it is the resource manager does resource management, whereas the application master or this new job tracker per job does job lifecycle management. Now it turns out that as we profile the job tracker code, we've known for a while that application lifecycle management is actually significantly more expensive than resource management, right? If you know the details of MapReduce, you guys might be familiar with things like counters, speculative execution, and so on. All these things cost a lot of CPU in the job tracker. By moving this out to a per application app master, we can now scale the system by a couple of orders of magnitude, right? And that's really, really huge. So that's why you have YARN. So now what happens is, as your client submits a new job, the first thing which happens is you get a new application master, right? Now this application master comes up in what we call a container. Now in YARN, a container is basically a way to get resources in the system, right? A container just represents, it's a logical container, it's a logical concept. It just represents a small amount of CPU, disk, RAM, network I/O, whatever it is. So it basically represents a bunch of resources you have, and then you can run whatever code you want in each of these containers. The first container for your application will run the application master, right? This application master is going to come up, and he's going to then start getting resources from the resource manager, right? He's going to say, I'm a MapReduce job, I need 10 maps and 3 reducers, right? The resource manager says, okay, depending on what else is happening in the cluster, I will now give you these 10 maps and 3 reducers, or as resources or containers. It's the responsibility of the application master to go talk to the individual node managers on which the containers are allocated, and then start the containers, right? So this way, the application master can use these containers in any way, shape, or form. The MapReduce application master uses these containers to run map tasks and reduce tasks. The Tears application master uses it to do something else. The MPI application master uses these containers to run MPI jobs, right? So that way, we sort of completely separate out resource management from application management, right? So when it comes to Tears, so Tears actually has two core ideas. As we looked at MapReduce, we realized that we didn't have to sort of look at every task as a map task or reduce task. You can generically think of every task as having an input, a processing element, and an output, right? So, you can model every map task and every task or every reduce task in these, input-output processor triplets. Obviously, you can have multiple inputs and reduces, multiple inputs and outputs. Now, then what you need is, in YARN speak, you need an application master to take a more complex DAG of these tasks and run them to completion, right? So if you sort of go back to, back isn't working. Okay. Anyway, so we'll talk to it. As you sort of go back to MapReduce, you just need to run a DAG which has maps and reducers. The Tears application master now has to run a more complex DAG of tasks, right? So on the left-hand side, we have what is called the logical DAG. On the right-hand side, I have what is called the physical DAG. So the logical DAG looks like this, and it sort of represents the SQL statement. It can be a filter and a join and a group by and an order by. At runtime, depending on the amount of data you have, you will sort of get different parallelism for each of these tasks, right? And that's what you see on the physical DAG there. That's interesting. Hopefully that's not the building breaking down. So, like I said, with Pig and MapReduce, you now get significantly more complex tags which can be expressed as a single MapReduce job. In this case, you have a simple select, join, and a group by. So, yeah, with Pig or Pig or Hive, in this query, like I said, you've got a simple join followed by a group by. So you can now, instead of having two MapReduce jobs which you see on the left, you can run a single sort of MapReduce reduce job, right? And as you can see, the big difference is you now no longer need to persist your data in between your first job and your second job to HDFS. And what's also important is if you look at the number of sort of tasks you need to run the same query, you don't need those sort of identity maps that you see in the first tag here. Let's see if I can show you that. Right. So in this case, you don't need these extra maps here because they're done, as part of the previous tasks themselves, right? So an even more complex example looks like this, an even more complex query. And as you can see, instead of going from having 4 MapReduce jobs, we've gone to a single job. And along the way, if you guys understand Pig or Hive, they use a bunch of these identity mappers, which are now gone because you don't need to read that data from HDFS at all. They're going straight from that reduce to another reduce here. So you completely bypass HDFS. And sort of that's it. Hopefully, this sort of gave you a good overview of the past and sort of the future with Hadoop, with data processing in Hadoop. I think we probably have 5 minutes or so for questions. I'll definitely hang around in the lobby if you guys want to stick around and ask more. Questions? You guys are a shy bunch. So the question is, YARN like a distributed system for dealing with data? In some ways, yes. I mean, so that you have Unix or Windows which work at the per node level. What this gives you is sort of a system which can manage not just a single node, but a set of nodes at your cluster, at the level of a cluster, right? So there are interesting integration points we're exploring with things like YARN and OpenStack and all of these things. We'll do more work. But at this point, in the Apache Hadoop ecosystem, you can sort of say that, yeah. That's a good analogy. The question is Tears going to be accepted by Cloudera Mapper? I can't answer for them. But it's in the ASF, so it's completely Apache license. It's in the Apache Software Foundation. There's a significant difference between the two of them. You can have Apache licensed software, but not in the ASF. The reason you want to look at something in the ASF is because it gives you the guarantee that the copyright is owned by the ASF and not a single entity. Any more questions? What would be a good strategy to migrate to YARN? Interesting question. In the sense that what we are looking forward to do is to make sure that you have to do nothing to migrate to YARN, because you're continuing all your existing applications, whether it's MapReduce or Pig or Hive, will continue to work. It's sort of behind the scenes. So if you understand sort of what MapReduce does today, is you have a job client who will submit the job to the job tracker. What we've done is done work in the background, so the job client, instead of submitting the job to the job tracker, submits to the YARN resource manager. So from the end user perspective, it's completely transparent. Hopefully the positive part is that it runs a lot faster on YARN. MapReduce runs a lot faster on YARN. So that's the non-transparent part, but hopefully that's a positive surprise. Any more questions? I see Suresh waiting for his next talk. I'll hang around if you guys have any more questions. Last question? So the question is, the resource manager seems like a single point of failure. Yes. So we've done the work to make sure that there's this resource manager state is saved up, and we can sort of seamlessly have it come back up on a different node if necessary. His state is stored either in Zookeeper or HDFS, and we can recover that state from either of them. Okay, thanks guys.